or objectives. Number 1. Identify the parameter to be rated given a real-life problem. Number 2. Formulate the appropriate null and alternative hypothesis on population mean. Number 3. Identify the appropriate form of test statistic when A. The population variance is assumed to be unknown. B. The central limit theorem is to be used. And number 4. Identify the appropriate rejection region for a given level of significance when A. The population variance is assumed to be unknown. B. The central limit theorem is to be used. Number 5. Compute the test statistic. Number 6. Draw a conclusion about the population mean based on the statistic value and the rejection region. And lastly, solve problems involving tests of hypothesis and the population mean. So now, assuming that the population follows a normal distribution, the appropriate test statistic for testing a claim about the population mean when the population variance is assumed to be unknown and n is less than 30 is a t-test for a single mean. So this is the formula to be used. T is equal to x bar minus mu or the population mean all over S over the square root of n, where x bar is the sample mean, mu is the population mean, S is the standard deviation of the sample, and n is the sample size. So, let's have our example. According to the last year's report, a grade 11 student spends an average of 75 pesos per day for snacks. Suppose you recently took a random samples of 25 grade 11 students. You determined how much each grade 11 student spent for snacks each day, and results revealed a mean of 65 pesos and a standard deviation of 5 pesos and 50 cents. Using a 0.01 level of significance, can it be concluded that the average amount spent per day for a snack of a grade 11 students has decreased? Assume normality over the population. So now let's have first our given. So the mu is equal to 75 pesos, which is the population mean. And x bar is equal to 65 pesos, which is the sample mean. And S is equal to 5 pesos and 50 cents, which is the standard deviation of the sample. And n is equal to 25, which is the sample size. And A is equal to 0.01, which is the level of significance or alpha. So now let's have our critical value method. So let's have our step 1. State the null hypothesis or H sub O and alternative hypothesis or H sub A. So for H sub O, so for our null hypothesis, H sub O, our symbol here is equal, so mu is equal to 75. So our population mean is 75. So this is now our null hypothesis. How about alternative hypothesis? Again, we have 3 symbols that we can use, which is the greater than, less than, and not equal to. But in this situation, we are going to use less than. So, we have mu is less than 75. So why is Why less than? Because if you notice in our given example, the word decreased, and decrease is just the same with the less than. So our alternative hypothesis, we have mu is less than 75. So why? And next we have our step 2, significance level. Alpha is equal to 0.01. Next, let's have our step 3. Compute the test value. So since it is the population mean that is being tested, the population standard deviation is unknown, and n is less than 75. The appropriate test statistic is the t-test for a single mean. So let's have our computation. So here is the formula that we are going to use. T is equal to x bar minus mu all over s over the square root of n. And now let's have 65 minus 75 all over 5.50 over the square root of 25. And using your scientific calculator, you can solve this and you can get negative 9.091. And now, let's have our step 4. First, we're going to find the degree of freedom. So, to find the degree of freedom, we are going to use the formula df is equal to n minus 1. So, n is equivalent to 25, which is the sample size, minus 1 is equal to 24. And next, we are going to B, significance level. Alpha is 0.01. The alternative hypothesis is directional. Hence, the one-tailed test shall be used. Locate 24 in the first column headed DF because the test is one-tailed with alpha is equal to 0.01. Refer to the column headed 0.01 in one tail. The critical value is negative 2.492. There is a negative sign because of the direction of the alternative hypothesis, which is less than. So this is one-tailed left. As you can see in the graph below, the shaded region is at the left because it is negative. And now for the last step, draw a conclusion. The computed test statistic T is equal to negative 9.091 falls within the rejection region. Reject the null hypothesis. Using a 0.01 level of significance, there is sufficient evidence to conclude that the average price of snack in the school is more than 75 pesos. And that's all for this video lesson. I hope you learned something. Thank you very much for listening. Bye-bye.